Good morning and thank you for joining us. Today's webinar is on the LSS Boat, an easy solution for difficult TOC samples, presented by Joy Osborne, who is our TOC product line manager. We will be taking questions at the end of the presentation, but you are able to submit them throughout by using the question function. Okay, Joy, I'm handing it over to you.
Okay, thank you, Shelley, and thank you for that introduction. I want to welcome you all to this presentation. I'm really excited to talk to you about our newest product, the LSS Boat, which is an easy solution for difficult TOC samples. Today I'll be talking to you about choosing the right Teledyne Tekmar TOC instrument for your application. So I'll be talking about all our TOC products and where the LSS Boat fits into our product family. Then I'll be talking to you about our newest product, the LSS Boat. Also, there's two application notes that I'll be discussing that were performed on the LSS Boat. One was with difficult solids and one was with difficult liquids. So let's get into choosing the right Teledyne Tekmar TOC instrument. So here are three main TOC instruments. We have the Fusion, the Torch, and the Lotix. The Fusion is a UV persulfate system, so it uses UV like light and persulfate reagent to cause that oxidation reaction. It's great for low-level parts per billion and parts per million analysis, and it's usually used for drinking water and pharmaceutical applications. We also have the Torch, which is in the middle, and it's a catalytic combustion system, so use catalyst, a platinum catalyst, and a high heat to cause the oxidation reaction. It has a large range of analysis. It's mostly used for wastewater application. It is moderately priced, but it has a lot of features. And then we have the Lotix, which is also a catalytic combustion system with a large range of analysis. And it's great for wastewater samples and solids. It has less features, but it's more budget friendly. It's a lower cost unit. So you're probably wondering why we have two combustion systems. So I want to show you the differences between the Torch and the Lotix, which are our two combustion systems. So let's start with the similarities. They both use platinum catalyst that comes preconditioned. They both use lab grade air. And air quality is always important, so make sure that you use as pure as possible when running either of these instruments. They both have an optional stirring module, so if you do have particulates, you can buy that optional stirring module to get a more homogeneous sample. They both have pre-programmed methods, and these methods are great, especially when you're starting your method development. A lot of times I use these default methods. I don't even need to use a method that I had to develop myself. I can just use the pre-programmed methods, I would say 99% of the time. They both have easy to get to glassware, so when you do need to refill that 21% phosphoric acid or DI water, it's very easy to do so. They're on the exterior of the instrument. So you can easily clean anything or get to any reagent, which is really nice. You don't have to open up anything to get to them. They're both used from EPA methods like 415.1 and 53010B. Those are just examples. They're also good for other EPA methods. So now let's talk about the differences between our two combustion systems. So the gas handling on the Torch, which is number one on there, is done with a mass flow controller. This mass flow controller is very accurate, and it can change at any mode of the sample analysis. So you can easily get 10 mils a minute, 200 mils a minute, etc. While the Lotix uses a two-stage pressure regulator. So the pros to the mass flow controller, like I said earlier, is it's very accurate, and you can control the flow rate very easily. The cons is it adds more cost to the unit. So when we're developing the Lotix, we try to reduce as much cost for you, the end users, as much as possible. So we remove the mass flow controller. Okay, for the liquid handling, they have different liquid handling systems. The Torch uses a 7-port valve and syringe, while the Lotix uses 2 separate needles and internal valves, 12 internal valves to be exact. So the benefits of a 7-port valve and syringe are that you can do things like dilutions, and you can pull various amounts of sample or liquid throughout the system. The cons to a 7-port valve syringe is they add cost to the instruments, and also the syringe is a consumable, so it will need to be replaced every so often depending on how much you use it. The Lotix uses 2 separate needles. It uses pneumonic pressure to fill up a sample loop, and that's how you get the correct sample volume. They have different trays, so if you want more of a variety of sample trays, you have that with the Torch. You have a 75, a 90, and a 120 position carousel, while the Lotix only has 1 style tray, which is a 30 position conveyor. They both use a NDIR detector. One is pressurized and one is a flow through. They both have very large analytical ranges. The Torch is 50 ppb to 30,000 ppm, while the Lotix is 0 to 20,000 ppm. And the reason the Torch has a slightly larger analytical range is because it has that dilution capability. So it can dilute those samples for you and get it within that calibration curve range. Okay, they both have different features. So the Torch has a lot of software features, including 21 CFR 11, which is used in pharmaceutical to record any changes that you've made throughout the analysis. It has an optional total nitrogen module, so you can do a TN analysis with the Torch. As IntelliDilution capabilities, this is when your sample is over the range of your calibration curve. The software will know that it is, and it will actually dilute it for you if you tell it you want it to, and it will dilute it back inside that range. So you don't have to rerun it in the morning with a higher calibration curve if you see that happen. It has auto calibration capabilities, meaning you only have to have a stock standard, and then it will dilute to whatever levels of standards. It will make those serial dilutions for you, which is really, really nice. The Lotix has features too. It has the solids module, which we'll talk about much more in depth later. It has a faster runtime, and you can get less than 15 minutes for a triplicate, and has very easy to use software. Since there's less features, the software is a lot more simpler, so you can really just walk up and use it, which I'll talk about further later. If you're still confused about which Tekmar TOC instrument is the right one for your laboratory, you can ask yourself the following questions. First of all, you want to look at your sample matrix, and you want to say, is it a liquid or is it a solid? If it is a solid, then you want to go straight to the Lotix with LSS. The LSS is the boat module right here. If it's a liquid, does it have particulates? And if you answer no, then you need to ask yourself, what is the carbon range? If it's a lower level, you're going to want the fusion. If it's higher level, then you're going to need to ask yourself, what's more important, low price, speed, or features? If you pick price and speed, we would recommend the Lotix. If you pick all those neat features like the auto calibration and IntelliDilution, we would recommend going with the Torch. Also, I want to go back up here, and if you do have particulates and they're greater than 0.8 millimeters, then we would recommend the Lotix with the LSS. So the limiting factor here is the needle diameter. The hole in the needle's diameter is only 0.8 millimeters. So if it's larger than that, then it's not going to get in that needle, and it could actually clog that needle. And if you still don't have a clear picture, which I hope you do by now, of which one's the right TOC instrument for you, here's a very easy visual test you can ask yourself. If your sample is very clean, it's something you would drink, we would recommend the fusion. if it's a little bit more cloudy, it's from a waste stream, it has some turbidity, then we would recommend the torch or the Lotix. And that's when you would have to ask yourself, do you want the fancier one or the more simple one that's low cost? And then if your samples look like this, like the bottom of a swamp, then you definitely have to get the LSS boat. So hopefully now you have a good idea of where the LSS boat fits into our product family picture. So now let's go and talk about our newest product, which I'm really excited about, the LSS boat. So here's a picture of it and attached to the Lotix. So once you plug it into your computer, there's one USB cord that comes out of the LSS boat. The software will automatically know that it's connected. So you don't have to do anything. You don't have to tell it that it's connected. And all those LSS Boat features will automatically pop up. So that's really, really nice. It makes it really easy for the user. Now there are 3 easy connections to hook up the Lotix to the LSS boat. There's one that you only need to do when you first install it, and it's you actually cut into the pressure line into your water reservoir. Since it's a positive pressure instrument, we use positive pressure for the water reservoir, so you cut into that, and that provides backflow, which I'll explain more later. And then you basically, all you have to do is disconnect the furnace in and disconnect the furnace out, and you remove it from the Lotix furnace, which is right about here, and now you're using it on the LSS boat furnace. These 2 connections are quick connections, so they literally just snap in and out. There's no wrench, no tools needed, so it should take very little, minimum amount of time to switch over for you. All right, so here are some basics. It's a semi-automatic solid sample delivery system. It uses catalytic combustion oxidation. It does TOC, which is the same as NPOC, because you've already removed, we don't count the purgeable organic carbon, because it's usually less than 1% and it's a known loss. And TC analysis of soils, sediments, sludges, and particulate-laden or turbid liquids. Okay, and here are the specifications. Sorry, one second. So the combustion furnace goes from 680 to 1,000 degrees C. So you do have some control over the furnace temperature on the boat. I already said it does TC, TOC, and NPOC analysis. And the boat material is quartz. So the boat is the piece of the instrument that you weigh the sample into. It's a little concave. It looks like a boat. That's why we call it the boat. And you would scoop that sand or dirt into it and weigh it out. And we chose to make that of quartz because it's the same material that the combustion tube is made of. So there's virtually no background coming. You should not get any carbon contamination from that quartz boat holder. The analytical is has a plus or minus 2% standard deviation for a mid-range standard, so it's very, very precise. And the boat can hold up to 1.5 grams of sample, but again, that depends on the sample matrix and the density of the sample. It can perform 0.1 milligrams to 20 milligrams of carbon, and the analysis time is 5 to 7 minutes or less, I've seen, at a gas rate of 20 mils per minute. It is also CE certified, which is a European Union safety regulation, so we have put it through rigorous safety testing. Here are the features of the LSS boat. It has an automatic sample delivery into the furnace. This means that you don't actually have to physically push that sample into the furnace. The boat will do that for you. It has fast analysis time, which I'll show you more later. And it's an easy switch between solids and liquids. It has a low cost of ownership. There's very few consumables on the LSS boat. You will need to change the catalyst, depending on use, but other than that, there's not many consumables on the LSS boat itself. It does have some of the same sample pathway as the Lotix, so you're still going to need to replace the condensate loop and those other regular consumables every once in a while. Has a very large analytical range, 0 to 20,000 ppmc. 0 is more of a theoretical, like you can just run DI or blanks on it. And it has very easy to use software. And so I'll talk about that automatic sample delivery furnace if you can't quite picture that yet. So here's a picture of it close up. And we recommend that you set it to 800 degrees C, the furnace, and you can see it glowing right here, so it's very, very hot. There is a protective lens over it to keep, people from touching it, but you can see inside of it in this picture. And while it's open, you're probably wondering, there can be carbon that comes in to that furnace while it's left open and open to the environment. So how we prevent carbon from entering into the furnace is we apply backflow pressure. So there's actually, when it's open, there's a flow coming out. And it doesn't stop until this is closed. And here's a picture of the quartz boat holder. So it just moves into the furnace. Here's a picture of the combustion tube that's inside. This one has been slid out. It's very easy to remove. There's 4 screws, and then there's 2 holder screws that you can jiggle and help pull it out right here. And you slide it out, and then you can pack it very easily. We recommend 0.5 grams of quartz wool at the bottom, 12 grams of cobalt oxide catalyst in the middle, and another 0.5 grams of quartz wool on top. And then there's a special packing tool that you use to pack it down with. So you'll just slide it in, do that, or slide it out, and then repack it, and then slide it back in and put those 4 screws back on. It's very, very easy. And this is a very basic of how TOC works, but I kind of modified it to reflect what the boat does. You don't really have to understand chemistry or be a chemist per se to really understand this. You have your carbon that's in your sample. We have a picture of some dirt here. And then you have oxygen, which would come from your air tank. And then you have heat and cobalt oxidation, which makes your CO2. Now you're probably thinking, well, that's only total carbon. Now you will have to, if you want to do true TOC, you will have to add acid manually to remove the IC from the boat. We recommend a 50% nitric to 50% DI water solution, and you want to inject that over your sample to cover the entire sample to remove any IC in the sample. And now let's talk about the easy-to-use software. So I'm going to actually show you some screenshots from the software so you can see how easy it is to actually use. All right, so here's the picture of the home screen of the Lotix. And you can see it just says Lotix, Combustion TOC, Lotix, Standby. Well, as soon as you plug in that USB cord from the boat, it will automatically know and your screen will change. It doesn't just change in the home screen, it changes throughout. This is the active status window. It's the window while it's running. Your furnace temperature for the Lotix will stay there, but it will add, which is, it's not there before the solid furnace temperature automatically to the screen. So everything you would need to know about the LSS boat will automatically pop up for you. And now I'm going to show you how easy it is to run a calibration. So we're back to the home screen. You're going to click Calibrate. Of course, for calibration, it's the orange button. And then this window will pop up. It's also orange, so make sure you know you're in the calibration screen. You're going to go to Methods. You're just going to click Solids, and the default Solids method was used for all my application notes. I really haven't had to change anything. It's a great method, general method to use for most applications. After you select solids, you're going to get your sample schedule screen, and we recommend running a clean, and we call this clean and not rinse because it's not a liquid pathway anymore, it's a gas pathway when you're talking about solids. We recommend doing like 1 or 2 cleans if you haven't run it in a while, just to make sure there's no residual carbon in your system. And then you're going to add your calibration standards. So when you hit this drop-down window, this box pops up. And then you can select which calibration concentrations you want to use. So if you're doing a low level or a high level, and you can add any more numbers that you want, anything that you've made, and then you just hit select, and then it will populate the whole schedule for you. And then you just hit start. So again, it would only take, maybe a minute to do this whole thing. And then it will run, and once it's done running, this box will pop up. I'm sorry, it's a little bit blurry. And it has all your results, and it shows your calibration curve and your R-squared value, which here we got 4.9, which is good. It will also, all these results will show up in your report. It's not just in this window. Another nice feature of the TechLink software that's on the Lotix and LSS Boat is that we have an outlier feature. So if you set it and you say, I don't want an RSV greater than 5%, then it will rerun a 4th rep. If, let's say you're doing triplicate, it will rerun another replicate to try to get you into that less than 5%. It doesn't have to be 5%. You can set it to 2%, 1%, 10%. But it will do that for you, which is really nice. It will run another one if it's not within your relative standard deviation that you desire. Here's a picture of the sample screen. So it's a little bit different when you hook up the boat. You will have to physically type in the weight of each sample. It will prompt you to do this when it's ready. The boat will come out, and you'll put the new boat in, and then you'll tell it how much you weighed out of that dirt or soil or very cloudy particulate-laden sample, and you'll put in the weight, and then you select which unit it's in, and the software will automatically take that weight and calculate it back to the calibration curve. The nice thing about this is that you can actually play around with how much you weigh out to get it within that calibration curve. For example, if you run a 0 to 1,000 ppm calibration curve and your sample is coming out at 2,000, but you weighed half a gram, you could easily weigh 1/10 of a gram, and as long as the absorbance counts come within that range, you're fine. So if you weigh 1/10 of a gram, you can get it within that calibration curve's absorbance count. So you can play around with that. If your sample is lower than your calibration, use more. If it's higher than your calibration, use less sample. All right, now let's talk about that fast analysis time. We keep telling you that, but I really like to show that this instrument can actually do that. So here's some screenshots. This is a low-level sample. It was run 3 times, and you can see it started at 5:35 and was done by 5:45. So we were able to do a triplicate in less than 10 minutes. But this is a low level, so if you have a higher level sample, it will take more time to get back down to that baseline. But you can still see it started a little bit before 10:40, and we had a triplicate done, by 10:50 to 10:53. So, it's definitely less than 15 minutes. I want to show you that it really is a very fast instrument, and you can get a lot of sample throughput. All right, now let's talk about our application notes that we've done with the LSS Boat. The first one I did was with different soil types. So we had basically collected different types of soil, like there was sand, clay, humus, ash, like those type of things where there's different types of particle sizes, different amounts of water in it. They have different minerals and salts and materials. So they're very erratic, and I'll show you pictures of them later how different they are. And then we ran them in triplicates to determine the precision of the LSS boat. And then we wanted to verify the accuracy of the LSS boat, so we actually were able to obtain a USGS standard, which is United States Geological Survey standard, which had a value that it's supposed to be at on the standard, so we wanted to make sure that it matched too. All right, so let's talk about, so you're probably wondering, how do you run standards? Because standards are liquids. How do you run standards on a solids module? It's actually very, very easy. So you take that quartz boat that we talked about, and you just pack it with quartz wool. You know, you can buy that from anywhere. And then you can inject, in this case we injected 50 microliters of each standard onto your quartz lined boat, and we ran it in triplicate. And we just used the standard KHP type standard, which I'll go through it a little bit later. So you just use, you can use either use a GC syringe, which works really nice to do the 50 microliter, or you can use an airsoft syringe, airsoft pipette, I should say. All right, here's the default solids method that was used throughout this application note. I didn't change anything. We didn't change anything on it. There's only 4 parameters you really can change. The boat cool down time, that's just the time the boat it takes to come out of the furnace. So if you want to up that to make sure it cools down completely before you put another sample in, you would up that this value. And then we have a carrier gas delay that you can change. And then we recommend you just turn the Lotix furnace off, because you're no longer using that Lotix furnace, you're only using that LSS furnace. So 0 is off. And then you can change the LSS furnace temperature from 650 degrees to 1,000. Okay, and then now I'll go over how we prepared those standards. So first, I accurately weighed 10.625 grams of KHP into a weigh boat. Then I quantitatively transferred that into a 500 ml volumetric flask, and I brought to volume with DI water. And then I mixed it thoroughly to make sure the KHP was completely dissolved. And then from that stock solution, I made serial dilutions, and then I showed how I did it. So 5 mils of the stock into 100 mils gave me 500 parts per million. I do want to remind everyone, don't forget to use your good laboratory practices. And with that, I would recommend that you clean all your glassware with 5% nitric acid and water. Do not use, any acids that contain carbon, because that will contaminate it, or any acids that contain halogens, because halogens are really hard on that NDIR detector. So I would not recommend hydrochloric or anything like that. I would definitely, stick with nitric acid. And also to keep in mind your DI water. You want your DI water as low in carbon as possible. So make sure you have very clean DI water that you're using for everything. All right, so we ran these standards that I showed earlier that we made, and we showed very good RSDs. All of them were less than 5 except for that blank. And they were run in triplicate. So we saw very good precise results of the standards. And the only reason the blank's a little higher is because it's such a low absorbance count that any variation in that absorbance count results in a higher RSD. And then the calibration curve, I was really happy with this calibration curve. I got 5.9. So if you're not getting good results, remember you need to accurately inject that standard into that quartz boat. That could be a problem. So, since you are doing it, there could be there is room for human error, so you need to get a good technique of injecting it onto the quartz boat each standard. And then the sample preparation. So after we collected these various kinds of soil and sand and things like that, the first thing we did was we ground, mixed, and sieved them. So we tried to make them as homogeneous as possible, which, you know, sometimes is very hard with this type of sample matrix. And then we dried it in the oven to remove any more. This part, you can leave the moisture in it, but we just to make it more uniform. Then we placed in the desiccator to cool so it doesn't pick up any moisture. And then we weighed a new clean quartz boat holder. We weighed each sample into that and recorded that weight. And that's when you would type that weight into the software. And then we injected each sample with 21% phosphoric acid to remove any IC, and that's optional if you want TC or TOC analysis. And then we dried the sample again to remove the moisture and that acid and IC off the sample. Here's a picture of the samples after we did this all to them. You can see they're very, very different types of matrices, and they have very different particle sizes and shapes. All right, so we ran those samples that were pictured. We again got really good RSCs. They're a little higher than our standards, and that's just due to the nature of the sample because they are not all completely uniform. So you can see when you run them in triplicate, you might not get the same exact composition each time, but they were still less than 5%. Which is good. And we're able to run this huge analytical range on one calibration curve by, like for this one, that's really high. It's over 300,000 parts per million carbon. We weighed a very small amount of sample. And one that was a little bit lower, you can weigh more. So you can do that to get it in your calibration range. And then we checked the accuracy of the LSS boat. So we ran that United States Geological Survey standard. We ran it in triplicate, and we got a 1.9% RSC, which is very good. The software calculated it from the absorbance counts and got that it was around 95,000 parts per million carbon. And on the standard, it should say the acceptable range is in between 92,300 and 101,300, which it was almost right in the middle. So we felt like, you know, it's a very accurate instrument. So in conclusion, it passed the accuracy check because of the USGS standard, and then it showed good precision because the RSCs were less than 5%. And now I'm going to talk about what kind of liquids you can use with the boat, which is another application note we did. So let's just say you have a sample like this one. And if your bandwidth's slow and you can't really see the video, there's like pieces of used toilet paper swirling around this file. You can see that the particulates are greater than 0.8 millimeters. So this is the type of sample we'd recommend for the boat. With that said, the old methods, you have a sample like this, you used to like try to run it as is, but the problem with that, if you try to run a sample like this, it will clog the needles, the liquid handling needles, the tubing and valves, so you can get clogged, which causes all kinds of problems. You can try to dilute it, but if it's already low in carbon, then it's going to dilute it too much and it might be below your calibration range or your detection limit. You can sieve it or filter it to remove those particulates, but then you're removing part of the sample, so you're not getting a good representative result of that sample if you start removing parts of it. So we would recommend the LSS boat for a sample like this. So the purpose of this application note was to run particulate-laden liquid samples on the LSS boat. And we had 3 samples from an agricultural waste stream that we collected. So they had, it was very cloudy and turbid, and you could physically see particles. And if you left it on the counter, you know, they would fall to the bottom. And then we again ran a calibration curve. This time it was 0 to 10,000. We got good RSCs again, except for the blank. Okay, and then this is the window that popped up. We got 4 9s for our linear regression, 0.9991. And then I ran the samples in triplicate again. And you can see we got a large range in that calibration curve. We had a sample that was a little less than 200 and a sample that was almost 10,000 parts per million of carbon. We were able to do it all on the same calibration curve because we were able to play around with the weights of each sample. And then I ran a check standard just to make sure the calibration curve was still good, which it was. It passed. And it showed good RSCs. They're all less than 5%. And that's really hard with a sample that's cloudy and not homogeneous. So in conclusion, you can get great precision and accuracy on a variety of samples with the LSS boat. It's very easy to use and operate. I had no problems, you know, with the software. Hopefully you won't either. The LSS boat provides, so in conclusion, the LSS boat provides an easy solution for those difficult TOC samples.